Hello everyone, today's lesson is on relations and functions.
The same topic we'll be dealing with is relation and function 2. Under this lesson, we'll be dealing with mapping, functions, and examples on the functions. It's very, very important. Mapping. Now, talking about mapping. Mapping is a relation in which each member in a domain maps onto only one member in the codomain. Okay, so from this definition, we then can say that what a one-to-one mapping, or a one-to-one relation, and many-to-one relation are mappings. Very, very important for you to know here. So, with that being said, it's important for us to know that. Now let's test our understanding of this concept mapping. Which of the following relations shown in the arrow diagram is or are mappings? Which one is? And then the next question is, which one is one-to-one? These are the diagrams that we're given. Now looking at these diagrams, which one is or are mapping? Now looking at, let's start with the first one, the eye. Now looking at the eye, this or we can say all these diagrams here are relations. Now talking about the eye, we see 0 is related to what? The 0 or element of each one of the domain. The element of the domain or each element of the domain maps to what? Each element of the codomain. Yes, and as we can see, 0 maps to that, or 0 is related to that, 1 is also that, and 2 also matches to 4, 3 matches to 6. So we can see each one is to the other. So 1 is to 1, 1 is to 1, 1 is to 1. Great. So we conclude this obviously is a one-to-one relation. So this is a one-to-one relation. Now, remember what we said earlier. We said one-to-one relation and many-to-one relations are mapping. Remember that. And so we know that what? So we can conclude then that this R here is a mapping and is one-to-one. So obviously from this particular question that we asked, which one is one-to-one? We've answered that, and that's I, right? Is one-to-one. Now, let's consider the next one. Now, consider the next one, which is what the II. Looking at this particular one, this element of the domain matches to the element of the codomain. This one also matches to the element of the codomain. But however, this 3 has no match. It's not matching to anything here. So we can then say that what? This is obviously not one-to-one, and this is also not many-to-one, right? This is also not many-to-one because each one is mapping to the other one. So we can then say that what? This is not a mapping. Now, the third one, we can see 1 mapping to 2, 2 mapping to what? 2. So we can see what many has to do with what? 2 or more. So you see here 2 or more elements of the domain mapping to what? 1 element of the codomain. And then 2 mapping to 6, 3 mapping to 6, and then 4 mapping to 8. So by this we can then say that what? I, which is the third I, is what? Is also it's a many-to-one relation, and it's mapping. So and that's what you have. Functions. Let x and y be two sets, and this x and y, okay, and they being two sets here, they being two sets here, as you can see, like this. This is our x, this is our y, so with that being said, we have our function, and this function is an f function mapping from x to y, and this is read as what? The function f from set x to set y. Take note of it, very important. That's how we read it. We say what? This relation is known as a function from x to y, which is written as this. Okay, a function f from set x to y, or the equation as you can see, where f of x or y is the image of x, as you can see on your screen here. Yes, and so from this we can tell that the domain, we know this to be the domain. Okay, we already said that in our earlier video, the part 1 of it. We said, we talked about what the domain is. Yes, and this is the codomain. So let me use this to note that. So codomain. So here, this is our domain. This is our codomain. Keep in mind, we already talked about this. Range is a subset of a codomain. Okay, so the images that you can see here are the range. The one that is not mapped to or matched to is it's not an image, it's not a range, so it's a part of the element of the codomain, as you can see. Okay, functional notation. Given that f of x equals that, as you see on your screen, and then by definition, if we substitute any value of a domain or x value to be 1, this is the value we get, and this value is termed as the image or the range. Now if we do the same for f of 2, that is replacing the x to be 2, this is what we get. We get 7 to be our answer, and that becomes the next one. So here, so you see, as you can see, 2 mapping to what? 7. Okay, so in terms of notation, that would be 2 mapping to 7. So that will be this. Which is our domain, and this our codomain. So we have here 1, and there we have here 2. And so by the function, 1 maps to what? As you can see on your screen, that's 5. So we have 5 here. And here, 2 maps to what? As you can see on your screen, that's 7. Right? Great. Now let's consider an illustrative example here. Make use of these information we have. A function is defined by f of f mapping f, where x is mapping f is mapping from x to 2x minus 3 on the domain. So these are the domain that we've been given, as you can see on your screen, and we're told to find the range of the function. So to find the range of the function, all we have to do is to replace. First of all, we have to define the function, and in defining the function, this is what we get. So we have f of x equals to 2x minus 3, and so what we do is replace or fix in each one of the values of the domain. So we fix it in there, and then the values we get for each one of them becomes our range or image. So here, if x equals minus 2, this is what we get. Our answer to be minus 2. So minus 2 multiplied to 2 gives us negative 4, minus 3 is negative 3. -7, sorry. Now if x equals -1, then replace the x with -1, and this is what we get. And so we do the same for every one or each one of the values of the domain. And after doing so, the next thing we do is what? We write down all the values. So as you can see, these are the values we have. Okay, this is 1, this is 2, this is 3, sorry, this is 4, and this is 5. So as you can see, so we have -7, -5, -3, -1, and 1, sorry. So that's it then. Example. Now a function is defined by the function f, mapping from x to 3x minus 1, or divided by x minus 3 on the domain of that. So these are the domains that we've been given. Okay, we're going to make use of them. So we are told to find the images of the following element of the domain. So here, okay, so since we've been given a domain, okay, we've been given a domain, that's good, great, so but however, here we're told in R, you're told to find the domain, find the images, of each one of these, that is 0, 1, and 2. So we don't have to stress ourselves by finding -2, and then -1. All we have to do is just find these ones, because that's what they're asking us to do. Now the next question is, what element of the domain corresponds to the following images? So however, one thing, even though, okay, now here, since we've given a different domain here, which is 7 out of 5, okay, we do have our function, so we could use this function, okay, plot the value in there, and I mean it will give us the image of this value. What value of x makes the function undefined? Now when we talk about undefined, what that means is that what value of x makes the function not to exist. Now that means that all we have to do is fix a particular number in the denominator where x is, okay, or where x is, wherever we find our x. Now if we replace the x with a particular value, that makes the denominator 0. As long as the denominator is 0, that means that the function does not exist, or the function is undefined. It cannot be defined. That's what it means. So whenever you come across a question that says define the value of x, that makes the function undefined, that means that just replace your x with a value that makes the denominator 0. So obviously, look at this particular example here. We have our x minus 3. If I replace my x with 3, I end up getting my denominator to be 0, and that makes this function not to exist. Therefore, that is this case. So here I have or another way where you can do this is equate the denominator to 0 and find your x value, and that's voila, you're done. Okay, now the next question is determine the range of the function. So as we know, yes, so all we have to do is to fix all the values of this one by one into the function of x, and whatever image it gives us or value it gives us is what we regard as and that's what gives us our range. Okay, so solution. So this is the function that we were given. This is the definition of it, and so all we have to do is find our image of 0. Sorry, the image of 0 is given by this. So fixing 0 into it, and this is what you get here. The image of 1 is given by this, f of 1 be equal to that. Fix the 1 in there, and this is what you get here. And the next question, the image of 2 given by this, so we fix in 2 there, and this is what we get. Now the next question here is, what element of the domain corresponds to the following image? 7 out of 5, fix. Now wait, it's very important here, what element of the domain corresponds to the following images? So here it's talking about the domain, so we are to find a domain. So here now, since we've been given our range, okay, this is our range, are we told to find its domain? So to find the domain of this, is different. All we have to do is equate this function to the 7 out of 5. Now that is it. So 7 out of 5. So you see this whole expression here as we equate it to 7 out of 5, and so this is what we have. So the next thing we have to do is to cross multiply and make it x the subject, or x, find x, the variable x. So we cross multiply, and you know what I mean by cross multiply, I mean that what this x minus 3 here goes to what, multiply the 7 here, and this 5 goes there to multiply what, the expression here, the left hand side. And so that is what you see here. So 5 went there, okay, so that's what we have, and 7 goes there to the other side, and that's what we have here. And this implies that what, so from there we can then go ahead and what, expand. So 7 multiplies to this and we get this. Sorry, 5 multiplies to this and we get this. 5 also multiplies to the 1 and we get that. And bring our equal to sign, and then 7 multiplies to the x and we get this, and then 7 multiplies to the 3 and we get this. So here we have our x to be equal to -2. Therefore, the element of -2 of the domain matches to the image 7 out of 5. So this is the answer we get, and so that's the domain of the image 7 out of 5. Move to the next question. Here we do the same thing for the 1, equate it to 1, cross multiply. Cross multiply, that's to say that what, keep in mind, every what whole number there is always a 1 beneath that number. Any number that you have, there's always a 1 beneath it. So therefore we cross multiply. 1 goes there, 1 goes to comes. This expression also goes to where the 1 is, and this is what we have there. Okay, so 1 multiplies this, the same thing, 1 multiplies that, the same thing. Next thing to do is to what, find x. So we have our x to be -1. Therefore 1, the element 1 is one of the domains of the image. So now the next thing is the function is undefined. Just as we said earlier on, all we have to do, okay, is just go straight, equate the denominator, as you can see on your screen there, that's the denominator, and this denominator we equate it to 0, and that's what we've done here. So we equate it to 0. After equating to 0, and then all we do is to find x, and then this is the value we get. From there we move on ahead to find what, the range. Now in finding the range, now since we found some of the domain, some of the range of the others, which is the 0, 1, and 2, it's best for us to go ahead and find -1 and -2. So we do the same. So we find that, and by so doing, if you substitute your x value into your -2 and -1 into the function, this is what we get, 7 out of 5. And then the next one is 1. Attention, it's important for you to practice. At least try 10 examples under this. There are a lot of questions you find on the website, and it's important for you to practice. Try 10 or 20 more questions on your own, to just familiarize yourself with it and help yourself. And beside that, there's a homework for you to try your hands on. These are the homework for you. And this brings us to the end of the class. This is KK Mathematics, the solution to your mathematics. Thank you for your attention. Bye for now.